Hello everyone, I welcome you all to the lecture 3 of this course Construction Methods and Equipment Management. So in this lecture we will be discussing about the equipment cost estimation. Specifically, I will discuss about the ownership cost using time value method. So let us have a recap of what we learnt in the previous lecture. So in the previous lecture I introduced to you what are all the components of the ownership cost. We have discussed about the different depreciation accounting methods. Then we worked out a problem on how to estimate the ownership cost using average annual investment method. Okay, so this is the outline of today's presentation. In today's presentation, I will just introduce to you what is the time value of money. So as I told you earlier, like the cash flows are occurring at different time period. So we have to convert those cash flows which are occurring at different time period into equivalent value at a particular time period using various compounding factors. Okay, so how to use those compounding factors we are going to discuss in this lecture with some illustrations. Okay, and we will also work out an example on how to estimate the ownership cost using time value method in this lecture. Let us see what is this time value of money. As everyone knows that value of money changes with time. Okay, it is known concept to everyone. So basically if I borrow say 100 rupees from bank today, okay, so if I am going to return that 100 rupees after 1 year, I cannot return the same 100 rupees. I have to add some interest to that particular principal 100 rupees, okay, and I have to return back the principal plus interest together at the end of 1 year. Okay, so how much will be the interest rate that will be decided by the bank? It depends upon the compounding rate of interest followed by the bank policy. Okay, so according to the bank policy it will vary. So basically the bank or any borrower is charging you the interest for the money whatever he is lending you. The reason why they charge the interest everyone knows. It is because they are taking risk by lending you the money. For that particular risk they are charging the interest so that they can get the profit. So the interest is nothing but the earning power of the money. It's nothing but earning power of the money. So in another perspective you can say by giving the 100 rupees to the person, the person who is lending is losing the freedom of using that 100 rupees. Okay, to compromise that he is charging you this interest kind of rent. It's a kind of rent we pay for using his money. Okay, so in different perspective you can define it in different way, but basically interest is the earning power of the money. So basically time value of money is the difference between the money borrowed for use today and returned at the future date. So when I borrow 100 rupees from the bank, so if it is going to be compounded at the interest rate of 8%, then after 1 year I am supposed to return 100 plus 8 by 100 into the principal amount. Okay, this is your interest. So the total money which I have to return after 1 year will be rupees 108. Say if I am not able to return the money after 1 year, I am going to return it after 2 years. Then what happens? Your interest will be compounded. Okay, now you have to calculate an interest for the new principal 108. So 108 plus 8 by 100 into 108. So this is the amount which I have to return to bank after 2 years. So it comes around 116.64. So the thing we have to keep in mind is all these three values are equivalent. The 100 rupees today and rupees 108 after 1 year and rupees 116.64 after 2 years. Okay, all these are equivalent. They are not equal, but economically they are equivalent. So this is called as economical equivalence. That is, they are going to create the same effect only. So this is a concept of equivalence. They are made equivalent at the compounding interest of say 8%. At 8% compounding interest, they are made equivalent. So economic equivalence is a combination of the interest rate and the time value of the money to determine different amounts of money at different time periods which are equal in the economic value. So basically these equivalent cash flows will result in same result over a period of time. So the result is going to be same. That is why we say they are economically equivalent. Though they are not equal, they are economically equivalent from economic perspective. So in this time value method, so basically you have to understand the time value concept, okay, and the compounding factors. So what are all the different compounding factors which are generally adopted to convert the cash flows which are occurring at different time period to a particular time period, to equivalent value at a particular time period. Those compounding factors you should know. So this is a prerequisite to estimate the ownership cost using time value method. So that is why we are going to learn what are all the different compounding factors available and what are the applications of these compounding factors and how to make use of them. That is what we are going to discuss in the upcoming slides. Okay. Using time value concept, we will learn how to convert the cash flow occurring at one particular time period to equivalent value at another time period. So that is what is the main purpose of this time value concept, so that we can have a rational comparison of cash flows at different time periods, which will be more sensible. So this shows a typical cash flow diagram. Okay, cash flow diagram is nothing but a graphical representation of the cash flows which are occurring at different point of time. So basically the horizontal line indicates a time period, the time 0, okay, whatever the cash flow occurring at time 0, it indicates a present value. Okay, this is a present value. Year 1, 2, 3, 4, everything indicates the end of the year. So you have to remember that year 1, 2, 3 means it indicates the end of the period, and the cash flows which are pointing downward, so they are cash outflows. So basically your expenditure is your cash outflow. So cash outflows are represented as arrow pointing downward, and cash inflows are represented as arrow pointing upward. So all your revenue, income, your receipts, so whatever is the cash inflow. Say for example, if you are going to sell your equipment at the end of the useful life of the machine, that salvage value is your cash inflow. So that will be represented as arrow pointing upward. So these things we have to remember in mind. So we are going to use the cash flow diagrams to discuss the compounding factors. So now let us move on to the first important compounding factor which we need to learn, that is single payment compound amount factor. So this single payment compound amount factor is used to compute the future value accumulated after n periods from a known present worth at a given interest rate I. Okay, that means if you know the present value of an asset, we can find its future value. So future value is unknown. Okay, you know the present value, you would like to estimate the future value of that particular asset. Okay, so you know the compounding rate of interest I, and you know the n, what is the life, what is the period over which you are calculating. Then you can use this single payment compounding factor to estimate the future value. So basically, say for example, if I am investing some 1 lakh in bank, okay, so it is going to be compounded at the interest rate of say 8% for 8 years. So after 8 years, what will be the future sum of this present 1 lakh? That I can calculate using this single payment compound amount factor. Say, how will you calculate? Basically, the future value at the end of first year is nothing but, you know the principal value P. Now you have to calculate the interest for the principal, P into I. Okay, I is a compounding rate of interest. Now for the end of the second year, you need to find the future value. How will you calculate now? P plus P into I plus, you have to calculate the interest for this entire new sum now. So I into P plus Pi. So if you simplify, it will be P into 1 plus I whole square. Similarly, if you want to calculate the future value at the end of third year, F3, you will get P into 1 plus I the whole cube. So if you want to calculate the future value at the end of nth year, it is P into 1 plus I power n. Okay, so this is how we get this formula. F is nothing but P into 1 plus I power n. If I know the present value of a sum, I can know its future value, okay, at the end of n years, okay, if n is known and the compounding rate of interest I is known, I can calculate it. So now from the equipment perspective, we will see an example. Okay, a twin engine scraper machine, it is costing 82 lakh this year. Okay, if the rate of inflation is expected to be 5% per year for the next several years. I hope everyone knows what is inflation. So inflation refers to the loss in buying power of the currency. So the rate of inflation is 5%. What will be the estimated cost to replace the machine at the end of 9 years? Okay, so I know the present value of this equipment. Okay, I need to know the future value of the equipment at the end of 9 years. Okay, so I can use the same the single payment compounding amount factor. Okay, F equal to P into 1 plus I per n. I need to know the future value of the scraper. I know the present value of the scraper. I know the rate of inflation. Instead of interest rate, I am taking rate of inflation here. The life of the machine is 9 years. So it helps you to calculate the future value of the machine. So this compounding factor is very useful because you can know, say after 9 years, okay, if I wanted to replace this old machine with a new machine, okay, how much amount of money I may need. So that accordingly I can save that money in the pool of funds reserved for the equipment purchase. Okay, so this way it will be helpful in the equipment economics. Now the next important factor which we are going to discuss is present worth compound amount factor. It is just the inverse of what we discussed so far. So what is the single payment compound amount factor? F equal to P into 1 plus I per n. So now to find the present value, you just transpose the equation P equal to F divided by 1 plus I per n. This gives the present value. Okay. So in this case, the present value is unknown, but the future value is known. It is just the inverse of the earlier case. Say for example, if I want 10 lakhs after 8 years at the compounding interest rate of 8%, how much I should deposit now in the bank? Okay, how much amount I should deposit now in the bank so that it will grow to 10 lakhs at the end of 8 years at the rate of interest of 8%. Okay, so I can calculate using this the formula. So to calculate the present value, okay, I need the future value. The future value is known, n is known, I is known. I can find the present value. Okay, so you should know that the P is made equivalent to F. Okay, P is made equivalent to F by this factor. This factor is called present worth compounding amount factor. Okay. So let us work out another example from equipment perspective. Okay, a twin engine scraper is going to cost the same numbers I have used again. Okay, so that it is more easier to understand. It is going to cost 1 crore, okay, 27 lakh 20,891 rupees after 9 years. Okay, so you know its future value after 9 years. How much money we need to keep aside today so that money will grow to 1 crore 27 lakhs 20,891 rupees in 9 years at a compounding interest rate of 5%, and so that you can buy this particular equipment. Okay, so you know the future value of equipment after 9 years. So how much money I should now deposit in the bank at a compounding interest rate of 5% for 9 years. Okay, so that at the end of the 9th year I will be able to buy this particular equipment. How to plan for that? So how much money I should deposit now so that after 9 years I can buy this new equipment. So it is, we are going to find the present value. It is nothing but F divided by 1 plus I per n. Future value is known, compounding interest is 5%, number of years is 9. Okay, you can calculate. So it means now I have to deposit an amount of 81 lakh 99,999 rupees 0.76, okay, in the bank, okay, for 9 years at the interest rate of 5%, so that it will grow to 1 crore 27 lakhs 20,891 rupees. So that at the end of 9th year I will be able to buy this particular machine. Let us see the next important compounding amount factor. It is nothing but uniform series compound amount factor. Okay, so basically the payments, most of the companies you can see it will be occurring, the cash flows, payments or the receipts, all these are occurring in series. Say for example, if you are buying an equipment through loan, okay, so they are doing the loan repayment, okay, so that will be in series. Similarly, your receipts or revenue, all these things you will be receiving it in series over a period of time. Okay, so here we are going to consider only uniform series. Uniform series means in the series of cash flow, all the cash flows are equal in value. So note it very carefully, it is equal. All the individual cash flows, okay, are equal in value. A refers to the individual cash flow of this series of cash flow, and A is equal. So now what is the purpose of this uniform series compound amount factor? It helps us to determine the future sum of the known annual series with uniform amount A. So you know the series, okay, the series of cash flow, you know. The series is known, A is known. I need to find the future value of this A. The F is unknown, the future value is unknown. I need to find the future value of this A. Then I can make use of this uniform series compound amount factor. So basically, say for example, I am investing in bank. Say I am investing 1 lakh for 8 years. Okay, for 8 years. I am investing 1 lakh. At the end of every year, I am investing 1 lakh in the bank. Okay, at the end of every year, I am depositing same amount of 1 lakh. Okay, at the end of every year for 8 years at the rate of interest of say 8%. Okay, so at the end of 8 years, how this series of cash flows will grow into. So what is the future value of this series of investments or the deposits what you have made? That is what we are calculating here. So the series of investments or the deposits are known. What is the future value of the series is unknown. Okay, that is what we are calculating. So F is made equivalent to A, okay, by this factor. This is a factor called as uniform series compound amount factor. Okay, uniform series compound amount factor. So another important factor is uniform series sinking fund factor. So it is the inverse of the earlier case what we have discussed. In this, the series of cash flow that is unknown. The uniform series A is unknown, but your F is known. Okay, so this is used to calculate the annual amount A of the uniform series from the known future sum F. So your future sum F is known. Okay, I am going to find the equivalent A for that. Okay, the future sum F is known. I am going to find the equivalent the A for that. Okay, so it is just obtained by transposing the earlier equation. This equation, if you transpose it, okay, you will get the A value. So you are going to find the A from F, I and N. All these are known, this is unknown. So basically, how much amount of money I should deposit in bank, okay, every year, okay, for 8 years, same example, 8 years, okay, how much amount of money I should deposit for 8 years, okay, every year I should deposit same amount at the compounding interest rate of 8%. So that at the end of the 8th year, say I will be getting 10 lakhs. This is known. So I need 10 lakhs at the end of 8th year. For every year, how much I should deposit in the bank at the compounding interest of 8%. This A is unknown. That is what we are calculating here. So from equipment perspective, if you see, it helps you to calculate what is the equivalent value of the salvage value. See, you know that salvage value is the one which is occurring at the end of the useful life of the machine. It's a future value. So at the end of the useful life of the machine, you are disposing the machine or selling it at a reasonable price. That is what is your salvage value of the machine. Okay. So how to convert this salvage value which is occurring at the future, okay, into equivalent cash flows, into equivalent uniform annual amounts. So we can do that using this factor, uniform series sinking fund factor. So this is one application in the equipment economics point of view. So we are converting the salvage value which is occurring in future into equivalent uniform annual amounts using uniform series sinking fund factor. Now let us see an illustration from the equipment perspective. So how much must be deposited at the end of each year into a sinking fund earning 10% compounded annually in order to accumulate 1 crore 27 lakh 20,892 rupees for equipment replacement at the end of 9 years. So basically, so when we plan for the purchase of equipment or replacement of old machine with a new machine, so generally we don't prefer to use the entire revenue of one complete year, one particular year for the equipment purchase. Okay, so generally most of the companies won't follow that particular policy, because we cannot spend the entire revenue of the company of 1 year for the equipment purchase itself. Okay, there will be a lot of other commitments, so it may not be possible for us to do that way, and equipment cost may be very significant. Okay, so generally what do is they plan for the equipment purchase or equipment replacement in a systematic way. So there will be a particular pool of funds dedicated for the equipment purchase or equipment replacement, okay, called a sinking fund. In that particular pool of funds, they will deposit money. Okay, so every year they will be depositing some amount of money. Say for n years, this will be compounded at a particular rate of interest, say I percentage. So it will help you to either buy a new machine or replace old machine with a new machine at the end of that particular period. So that is how we plan for the equipment purchase or equipment replacement. We deposit some amount of money in pool of funds called as sinking fund. So that is what is this problem about. How much must be deposited at the end of each year into a sinking fund earning? So how much we should deposit into sinking fund earning? The rate of interest is 10%. So that my future value needed is 1 crore 27 lakhs 20,892. So that at the end of 9 years, I will be able to replace my old machine with the new machine. So this I can go for uniform series sinking fund factor. With the help of this factor, I can estimate this value. So you know the future value is known. You need to know what is the A. Okay, every year what should I deposit into the sinking fund. Using this compounding factor, I can estimate that. Okay, this is your uniform series sinking fund factor. A is unknown, okay, F is known, I is known, N is known. Using this you calculate. Now you know that every year I should deposit 9,36,773.34 rupees into the sinking fund, so that at the end of 9 years I will be able to generate an amount of 1 crore 27,2892. With that I will be able to replace my old machine with a new machine. So the next important factor which we are going to discuss today is uniform series the capital recovery factor. Basically this is used to find out the uniform amount A of a known series from the known present worth at a given interest rate I. So you know the present worth of a particular asset. Okay, the present value is known. How to convert it into an equivalent uniform series? P, the present value is known. How to convert it into equivalent uniform series? That is possible using this uniform series capital recovery factor. Say for example, if I deposit 10 lakhs in bank now, so for a period of 9 years I have deposited at the interest rate of say 9%. For 9 years I have deposited at the interest rate of 9%. So what will be the amount of money which I will get at the end of every year as a return? So that return is going to be in the form of equal amount of money. So that is what is A. That I can find it. If I know that I am going to deposit 10 lakhs now, at the end of every year, how much amount of money I will get from the bank as a return in terms of equal amount. So that is what I am calculating with this. So there are different applications for this uniform series capital recovery factor. It helps you in determining your loan repayment schedule. Say for example, if you have purchased your equipment through loan, so your lender will find out the loan repayment schedule using this uniform series capital recovery factor. Okay, see basically it tells you how to recover the capital invested, how to recover the loan which you lent to your borrower. Okay, so to find that I can make use of this uniform series the capital recovery factor. So one thing is your loan repayment schedule, and another, that is what we are recovering your the capital cost. Say another important application in the equipment economics is you know the purchase price of the machine. Okay, what you make at the beginning. Okay, that is the present value. Purchase price of the machine is known to you. The present value is known. How to convert it into equivalent uniform cash flows? How to convert the purchase price into equivalent uniform cash flows over the useful life of the machine? So how to convert purchase price into A? How to convert purchase price into A? So purchase price is known to you, A is unknown. So we can calculate using this uniform series capital recovery factor. So that is what is written here. It also estimates the equivalent uniform annual cost of owning and operating the equipment. You can convert the purchase price of the machine into equivalent uniform annual cost of owning and operating the machine using this formula. So this will help you in the equipment cost estimation, how to estimate the annual cost of the machine and how to estimate the hourly cost of the machine, which we are going to see in the upcoming slides. So another important factor which we are going to discuss now is your uniform series present worth factor. It is the inverse of what we discussed earlier. Okay, so that A is unknown, P is known. Okay, so here A is known, P is unknown. So it is just by transposing the equation you can find this uniform series present worth factor. It is used to determine the present worth of a known uniform series. So if the series is known, if the series of cash flows is known, what is its present value I can determine from this compounding factor. Okay, say for example for 9 years, okay, my plan is for 9 years at the end of every year I need 1 lakh as a rate of return from the bank. So for that, how much amount I should deposit now in the bank so that I can get the return of 1 lakh for 9 years at the end of every period over the period of 9 years. Okay, so I need 1 lakh money. Okay, 1 lakh at the end of every year I need a return of 1 lakh. Okay, for 9 years. So how much should I invest now? Okay, so that is what I am calculating from here. So I can find the present worth of the known series of cash flows using this uniform series present worth factor, which is nothing but a transpose of the earlier formula whatever we discussed. It is a transpose of uniform series capital recovery factor. So here you can see the P is made equivalent to A by this uniform series present worth factor. So let us now summarize what are all the different compounding factors which we have learnt. Single payment compounding amount factor, you know that to determine F for known P, I and N. So F is made equivalent to P by using this factor. So single payment present worth factor to determine P for the known F, I and N. P is made equivalent to F by this factor. For the uniform series payments, uniform series present worth factor to determine P for the given A, I, N. This is a factor which makes it equivalent. So this is to determine A, okay, the annual cash flow. You are determining the annual cash flow for the known P, I and N. This is the factor. Then the uniform series compound amount factor to determine F for given A, I, N. So basically to know what is the, if the current series is known, if you want to know the future value of the current series, then you can use this factor. Then sinking fund factor, it is just an inverse. So determine A for the known F, I and N. So they are made equivalent by this factor. So basically if you see that these two are inverse of each other. Similarly these two are inverse of each other. These two are inverse of each other. So if you know one, you can calculate the other one. You need not remember all the compounding factors. At least one of every important factors of this you should remember. Okay. So let me summarize what we have discussed so far. I introduced to you the importance of considering the timing of cash flows and how to use the various compounding factors to convert the cash flows which are occurring at a different time period to equivalent cash flows at a particular time period. Okay. So now let us proceed on how to estimate the ownership cost using this time value concept. Okay. The same problem which we have worked out earlier, but using the time value method. Okay. So estimate the ownership cost of the twin engine scraper machine, okay, using the data of previous problem what we have used earlier for the other method, it is average annual investment method. It's the same data we are going to use here, okay, but we are going to work out using the time value method here. So let me summarize the input data given in the problem. So the initial cost of the machine is 82 lakhs, okay, the tire cost is 6 lakhs and the estimated life of the machine is 9 years. So at the end of 9 years you will be able to sell this machine at a salvage value of 12 lakh. So the interest on the investment is 9%, insurance percent is 2%, okay, tax is 2.5%, storage is 1%, and fuel price is given as 60 rupees per litre, which will be used for operating cost estimation. Then the annual operating hours equal to 2400 hours. So the use of a machine in hours in a year is 2400 hours. Now let me recollect the important compounding factors which we discussed earlier, which we are going to use again now in the ownership cost estimation using time value method. So the important factor which we are going to use now is uniform series capital recovery factor. So basically this factor is used to find out the uniform amount A of a uniform series from the known present worth at a given interest rate I per interest period. Okay. So in this case your present worth of the money is known. Okay. You are going to find the uniform amount A. So for the given P we are going to find A. Okay. So basically we discussed about this factor earlier. It helps you to determine at what rate your capital can be recovered. So using this factor we can also find what is the loan repayment schedule for the equipment. So the lender will fix the loan repayment schedule using this uniform series capital recovery factor. So at what rate you can recover your loan, okay? What will be the loan repayment schedule, so that we can calculate using this. So basically for the given P you can find the A. Say you know the present purchase price of the machine P. So you can convert it into annualized purchase price or equivalent annual the uniform cost. So using this uniform series capital recovery factor. So the purchase price of the machine can be converted into equivalent uniform annual cost, okay, over the useful life of the machine using uniform series capital recovery factor. So we are going to determine A for the given P, you know the present value. So this is given, so okay, you are going to find the A. So you are going to find A. So this is your uniform series capital recovery factor. Okay. So the A is made equivalent to P by this factor. Let us see how to use this factor to find the annualized purchase price of the machine. Okay. So first let us calculate what is the purchase price of the machine less the tire cost. So 82 lakh is the purchase price minus the tire cost, because tire cost will be considered under the operating cost. Now the purchase price less the tire cost will be 76 lakhs. Now how to find the annualized purchase price from the uniform series capital recovery factor. So you know the P value, purchase price less the tire cost, that is 76 lakhs, multiplied by this uniform series capital recovery factor. Okay, you know the I value, okay, you know the N value, okay. So you can substitute it and find the annualized purchase price of the machine. Okay. So now you have converted the present purchase price into annualized purchase price using this uniform series capital recovery factor. Now let us move on to the next part. So now we are going to use this factor, uniform series sinking fund factor. Let us recollect what is this sinking fund factor. Okay. So basically it is used to calculate the annual amount A of a uniform series from a known future sum F. Okay. So if the future sum F is known, then you can convert it into equivalent uniform series A. Okay. So here you are calculating A for the given F. The future sum is known, okay, the future value of the particular the money is known. You are going to convert the future sum into equivalent uniform series A using this uniform series sinking fund factor. Okay. So now how are you going to use this in the ownership cost estimation? Let us see. You know the future salvage value of the machine. Okay. Salvage value is nothing but at what price you are going to sell the machine at the end of the useful life. So the future salvage value is known. You can convert it into equivalent uniform series A, that is you can convert it into annualized salvage value, okay. So using this uniform series sinking fund factor, okay. So here the A is made equivalent to F by this uniform series sinking fund factor, okay. Let us see how it is applied. Now the annualized value of salvage amount 9 years in future can be calculated using uniform series sinking fund factor as below. A equal to F, F is the future salvage value 12 lakh, Okay, you know the interest rate, you know the N. Okay, so this is your the uniform series sinking fund factor. Okay, so you can multiply the sinking fund factor with the salvage value, you will get the annualized salvage value as below. Okay, so now you know the annualized purchase price, you know the annualized salvage value. If you find the difference, you will get your depreciation. Okay, so that is what is a straight line method says, difference between the purchase price minus the salvage value. Here we are going to find the annualized value, then we will convert it into hourly cost. So hourly depreciation portion of the machine's ownership cost, we are calculating with a straight line depreciation method. Okay, it is nothing but your annualized purchase price minus your annualized salvage value divided by the annual use of the machine in hours. Okay, so the total hourly usage of the machine. Okay, total hourly usage of the machine. Say for example, every day you are using the machine for, every day is 10 hours. Okay, so you are going to operate the machine for 240 days in a year. So the total annual usage of the machine, okay, hourly usage of the machine in a year will be equal to 2400 hours. Okay. So this is how you calculate the hourly depreciation. Now let us calculate the other components of the ownership cost. So the other components of the ownership cost are taxes, insurance and storage. So they are expressed as a percentage of the initial cost minus the tire cost. So in this time value method, instead of taking the average value of the machine, we are calculating as a percentage of the initial cost of the machine. Okay, obviously you have to deduct the tire cost. So you add the tax component, insurance component and the storage percentage. So calculate the percentage of the initial cost minus tire cost, divided by the total usage of the machine in a year, total hourly usage of the machine in a year. So that is divided by 2400. So you will get the hourly cost as rupees 174.17 per hour. Now you are going to calculate the total ownership cost. So earlier whatever you have calculated the depreciation, and now you have calculated the other parts, taxes, insurance and storage, add both. This is your depreciation part, this is your taxes, insurance and storage part. Add everything, you will get the total ownership cost using the time value method. So you have calculated the hourly cost. So this is how you estimate the total ownership cost using time value method. Earlier the lecture I have calculated using average annual investment method, which was approximate without considering the timing of cash flows. Okay, so this is more accurate method. You can compare the cost using both the methods. Now let me summarize. Okay, so whatever we have discussed so far in this particular lecture on time value method. As everyone knows, value of money is changing with time, and we found that the compounding factors are very helpful to make the rational comparison of the cash flows occurring at different point of time. It helps you to convert the cash flows occurring at different periods into equivalent value at a particular period for making the analysis or comparison. So then we saw the application of this uniform series capital recovery factor. It helps in determining the loan repayment schedule for the purchase of the equipment. It helps you to determine at what rate you can recover the capital invested. Also it estimates the equivalent uniform annual cost of owning and operating equipment. It helps you to convert the present purchase price into annualized purchase price. So that is how we estimated the depreciation in the time value method. Hope you remember. Similarly, this uniform series sinking fund factor helps to estimate how much money must be deposited at the end of each year into the sinking fund earning annually in order to accumulate to the required amount needed for the equipment replacement at the end of the particular time. Say I told you about the sinking fund. Generally when we plan for the purchase of a new equipment or replacement of the old equipment with a new machine, so what we do is we deposit some amount of money into that pool of funds called as a sinking fund every year, okay, planning for the purchase or replacement. Okay, so that at the end of the particular period, that money will grow into a particular sum which will enable you to either purchase a new machine or replace the old machine with a new machine. So this sinking fund factor will help you to determine how much money I should deposit in the pool of funds every year, so that it will grow into the future value f at the end of the n years. Also, with the help of the uniform series sinking fund factor, I can convert the salvage value that occurs at the end of the service life of machine into equivalent uniform annual amounts. So, that is what we found in the time value method estimation. Okay. So, we converted the future salvage value into annualized salvage value using uniform series sinking fund factor. So, with this we have come to the end of the lecture 3. So, these are the important references which I have referred for this the lecture preparation. You can refer these textbooks for the course preparation. So, in the next lecture we will be discussing about how to estimate the equipment cost, particularly the operating cost. Okay, how to estimate the operating cost we are going to discuss in the lecture 4. Thank you.